Hi, this video is about the distributive property. So our objective for this video is I will understand how to apply the distributive property to algebraic expressions in order to create equivalent expressions. What does distribute mean? Well, that means to pass things out. We distribute money, we distribute food, we distribute your papers in class. I distribute your papers in class. We give them to people. So this is what we're working for. We want to create this expression, an equivalent expression with the fewest terms for here. All right, how do we do that? Well, the distributive property, this is what we use to get rid of parentheses. It allows you to take what's outside and distribute it to the inside of the parentheses. You already know how to do this with PEMDAS, order of operations. So think about how you would solve it. Would you solve it by adding the 5 plus 8 first and saying, well, 5 plus 8 is 12, not 12, it's 13, and multiply it then by 4 to get 52. And then over here, we could do the same thing. 7 minus 3, we have to do parentheses first, right? 7 minus 3, well, that gives us 4. And then we have to multiply it by 5. That would give us 20. That's how we've done it in the past, right? So why is it to get rid of parentheses when we already have our order of operations, right? Well, we have algebraic expressions that look like this. There's a variable inside there. We have to distribute the 5 to the inside. How would we do that? It's all about simplifying algebraic expressions. We can't add 8 plus x because they're different terms. So, what should I do? Well, I know that in the past I could just multiply the inside, so maybe I can try that. So if I multiply 5 times x, I'll get 5x, and then if I multiply 5 times 8, bring down that plus 5 times 8, well, that gives me, those constants, those are like terms, that would give me 40. So then this expression would turn into 5x plus 40. And that's all that the distributive property says. Let's try some more. The official definition of the distributive property is that it lets you multiply a sum by multiplying each addend separately and then adding the products together. Whoa, that's a lot of words, and I know that we've talked about addends, but it was just in passing. So what does that really mean? That means that you multiply the number outside of the parentheses by each term inside of the parentheses. Let's try some. Okay, well, here, I can't add the inside of the parentheses, so I'm going to use the distributive property to solve this. I can do 2 times x, and then I'm going to bring down my plus, and then 2 times 4. And now I have 2x plus 2 times 4, well, that gives me 8. And that's this expression in the fewest terms. Let's try another one. Uh-oh, this one has a subtraction sign in it. Well, let's think about it. 4 times x, that would give us 4x. And then 4 times negative 3 would give me negative 12. And that is my answer. All right. These look a little bit different. Let's try them. This first one has a coefficient on the d, on the variable. I hadn't done that before. Well, how do we do this? Well, let's do 6 times 5d. Well, 6 times 5d, that would give me 30d. And now I have 6 times negative 4. That gives me negative 24. So if I bring that down, my answer would be 30d minus 24. Okay, let's try one where the outside factor is negative 4. So I have negative 4 times x. That would give me negative 4x. And then I have negative 4 times negative 3. Remember that with multiplication, we can use Mr. Multiple Division, or if you have an odd amount of negatives, your answer is going to be negative, and if you have an even amount, it's going to be positive. Well, in this case, we have a negative multiplied by a negative, so our answer is going to be positive. Remember, that's 2 negatives, that's an even number, so it's going to be positive 12. Alright, let's look at this one. Y plus 3 in parentheses times 6. Well, that looks a little bit different. Well, we can still distribute the 6 into the parentheses. So 6 times 3 and 6 times y. Well, 6 times y is 6y, and 6 times 3 is 18. And that's all we do. Let's try some more difficult ones. Okay, here we have a negative 4. So we're going to distribute the negative 4 into the parentheses. So we are going to multiply it by each of the addends inside of the parentheses. So we have negative 4 times 2x. And then we have negative 4 times negative 5. Okay, well, negative 4 times 2x, that would give us negative 8x. And then we have negative 4 times negative 5. Well, that is positive 20. Okay, right here we have negative 2 times negative 3x and negative 2 times positive 7. So we have negative 2 times negative 3x, and then we have negative 2 times positive 7. Alright, so negative 2 times negative 3x, well, that would give us a positive 6x, because a negative times negative is a positive. And then we have negative 2 times 7. Well, I have a negative times a positive. That means that it's an odd amount of negatives, so that's going to be a positive. So I can just add 14 there. Okay, and then last one. Oh, dearie me. This one doesn't have just 2 things in the parentheses. It has 3 things in the parentheses. We can still use a distributive property for this. So we have negative 3 times 2x, and then we're going to do negative 3 times positive 3y, and then also negative 3 times negative 4. Alright, let's see how this looks. Negative 3 times 2x, and then that would be negative 3 times 3y, and then we have negative 3 times negative 4. So we have 3 different terms that we have to solve, right? Well, negative 3 times 2x, that would be negative 6x. And then we have negative 3 times 3y, that would give me negative 9y. And now I have negative 3 times negative 4, that would give me a positive 12. And so I've just put them together, and that is my equivalent expression with the fewest terms. Alright, now I want you to try it.